So again, just I have to continue after a minute break. Now let's go for the next system related to cockroach, the nervous system. So normally in the case of invertebrates, the nervous system is not well developed because we have no distinctive brain. But here, somehow we have to mention about slightly advanced animal, starting from if you are having the protozoans. Now this is somewhat slightly advanced. But if you are taking the cockroach, you have in the head only a bit of nervous system is present, not much as in our case. We have the brain, a controlling center. We have only a bit of nervous system present in the head region. Even if you are cutting the head, the animal can live for about a week because only a small segment of nervous system is present in the head region. That's why even if you cut the head, the animal can survive for a week without head. That's why there is an important character. Now, what are the components of the nervous system? As a general rule, if you are taking human being, we have a central nervous system, a peripheral nervous system, and an independent nervous system, what's called autonomous nervous system. Okay, we have three: central nervous system, peripheral nervous system, and autonomous nervous system. In our case, the central nervous system is formed of brain and spinal cord. We have brain and spinal cord, the central nervous system. So what about in the case of cockroach? Now in the case of cockroach, it consists of two components. One, what is called a nerve ring. A nerve ring. Another one, just what we have, a double ventral nerve cord. A nerve ring in the head and a double ventral nerve cord passing through thorax and abdomen. So that is one of the characters of invertebrates. The invertebrates have, we know that one, double ventral nerve cord, which are solid, running ventrally, solid, two in number. In our case, our nerve cord is dorsal, for example, the spinal cord, dorsal, tubular, single, dorsal, tubular, single. But in the case of invertebrates, double, ventral and solid. Now we have nerve ring. The nerve ring is formed of, that is, three components once again. So, any collection of nerve cells without specialized structure to form brain are called ganglia. Now here we are using the word ganglia. So spelling mistake is there. That is ganglia. Ganglia. So, we have a pair of ganglia lying above the esophagus. Suppose we have esophagus. This is the one above the esophagus. They are called supraesophageal ganglia, a pair lying above the esophagus, so-called brain. And similarly, below the esophagus, just below it, we have a pair of. So below it, we have a pair of ganglia. They are called subesophageal ganglia. Suppose now this is a supraesophageal ganglia 2 in number, and below the esophagus, we have a pair of ganglia, subesophageal. The same one in the case of, we see that one term is called suprapharyngeal ganglia because of the location lying above the pharynx. Here this is above the esophagus. Now the two being connected by means of a nerve ring. Now this is number one, that is what we call supraesophageal ganglia. This is number two, the subesophageal ganglia. And the two being connected by a nerve ring which is running around the esophagus, circumesophageal connective. So we have a nerve ring, it is formed of a pair of supraesophageal ganglia above the esophagus, a pair of subesophageal ganglia below the esophagus, and the two being connected by means of a ring, circumesophageal connective. Circumesophageal connective. Now we'll see in the picture. Now this one is what we have supraesophageal ganglia. Okay, and below it we have subesophageal ganglia, which is normally mingled with that one. And so that is not being there properly. So we have a mass is there above the esophagus. Now this is the ring connecting the two ganglionic masses. What here? Ganglionic masses. So that is about that one. That is the nerve ring formed of three components: supraesophageal ganglia, subesophageal ganglia, the connective, what is called circumesophageal connective. Then the second component of the what is called the central nervous system, ventral nerve cord. I mentioned earlier, it is solid in nature, double in nature, running ventrally, provided with the ganglia in each segment. Now, actually, it arises from the subesophageal ganglia. Subesophageal ganglia. Suppose, for example, this is the supraesophageal, the subesophageal, now the connecting. Now we have the double ventral now. This is what we have, the double ventral now arising from the subesophageal ganglia. Now, it runs up to what is called the seventh abdominal segment. Seventh abdominal segment. So it's being formed up, it is ganglionated, that means containing ganglia at regular intervals in the segment. Now there are three thoracic ganglia, one to each ganglionic mass. One to each thoracic segment. Three ganglionic mass. Prothoracic ganglion, mesothoracic ganglion, and metathoracic ganglion in the three segments of pro, meso, and metathorax. Now we have 6 abdominal ganglia. The first 4 ganglionic masses are found in the first, second, third, and fourth abdominal segment, whereas the 5th ganglion is present in the 6th abdominal segment. The 6th ganglion is present in the 7th abdominal segment, that is the largest abdominal ganglia, beyond which there is no segmental ganglia. So we have only 9 segmental ganglia, 3 in the thoracic region, 6 in the abdomen. The first 4, 1, 2, 3 and 4 are present in the first, second, third and fourth abdominal segments. Now the 5th ganglionic mass is present in the 6th abdominal segment. The 6th ganglionic mass is present in the 7th abdominal segment. The 6th actually the abdominal ganglia, thus we can see. So it arises from the subesophageal ganglia and runs to the 7th abdominal segment. There are 3 thoracic ganglia, 1 to each segment, and then we have 6 abdominal ganglia. This is one question. How many abdominal ganglia? I mentioned already number 1, number 2, number 3, number 4 in the first 4 abdominal segments. Number 5 ganglionic mass is found in the 6th abdominal segment. And number 6 is present in the 7th abdominal segment. That is the largest ganglionic mass. That's the largest ganglionic mass. So I mentioned already, the head has only a bit of nervous system. So if you cut the head, even after cutting the head, the animal can survive for what we have a long time. Then, see the peripheral nervous system. It includes those nerves arising from what we have the supraesophageal ganglia, subesophageal ganglia, circumesophageal connective, and the thoracic and abdominal ganglia. The nerves are given up, they constitute the peripheral nervous system. So it includes those nerves arise from different ganglia: supraesophageal, subesophageal, thoracic and abdominal ganglia. Now what are the nerve branches coming out from the supraesophageal ganglia? It supplies its branches to the sensory structures present in the head region, particularly the compound eye, antennae, the upper lip labrum. The subesophageal ganglia gives up the nerves, the remaining part of the mouth parts. We have the labium, the maxilla, you see that one, mandibles and the labium. So only one mouth part is being supplied with branches from the supra, that is the labrum. Now the remaining mouth parts, the mandibles, maxillae and also labium, all being supplied with actually now branches from the subesophageal. Now the thoracic ganglia supply its branches to the thoracic segments as well as the legs and wings, because the legs and wings are present only in the thoracic region. Now the abdominal ganglia normally giving out branches which innervate the organs concerned in that actually the particular respective segment. Now I will go for the picture once again. Now this is the one, what we have the supraesophageal ganglia, the various nerves that are arising from that one. Subesophageal ganglia, now this is I am just around and circling only subesophageal ganglia, and this one is a supraesophageal ganglia. Now this is circumesophageal connective. Circumesophageal connective. And other ganglionic structures, you see that one prothoracic ganglion, and this one is metathoracic ganglion. This is what is called actually mesothoracic, and then we have also metathoracic ganglion. This one is a metathoracic ganglion. Pro, meso and metathoracic ganglionic masses, and we have 6 abdominal ganglia. 1, 2, 3, 4, 5 and then 6. You see that one, The fifth one is present. The fifth one is present. You see, this is the fifth ganglionic mass, but present in the sixth abdominal segment. And the sixth ganglion is present in the seventh abdominal segment. That is the largest one, because it is the one giving branches to the remaining segments of 8, 9, 10, and also the anal stines, anal sarsi, and other structures concerned. So that's why we have the fifth one is present in the sixth segment, and the sixth one is present in the seventh segment. The sixth abdominal ganglion is the largest one. It is giving up branches to various organs concerned in the posterior parts of the body. Now let's go for the sense organ. Now the sense organs are in the form of actually sensilla and compound eyes. What do you mean by sensilla? The simplest sensory structures present normally in the animal body. Simplest actually sense organs are called sensilla. And these are normally found actually in the antennae, the maxillary pulps, the labial pulps, and also the anal cerci. The sensitive organs they have what we call the sensilla. So the sensilla may be of different types according to the nature of the stimulus they perceive. Either they are mechanoreceptors, or we have what is called actually that is chemoreceptors like olfactory receptors and gustatory receptors. Okay, now let's go for that one. These are the simplest sense organs and are concerned with actually receiving the impulses found in the antennae, then the maxillary pulp, the labial pulp, and also cerci. Now, there are different types of sensilla I mentioned already based on the reception of the stimulus. Number one, mechanoreceptors. They receive the mechanical stimulus. They are present on the basal segment of antennae, what is called the scape. The antenna is found up, you know that one, scape, pedicel, and flagellum, three common. The basal part by which it is attached to the head is called as a scape. Now it is present on the scape of antenna and also in the anal cerci. These two are containing the mechanoreceptors, receiving the mechanical stimuli, particularly the vibrations from the earth. Okay, so we have that is found simply on antennae, that is particularly at the basal segment, and also on the anal cerci found at the posterior end. The chemoreceptors that are concerned with the perception of what we have the chemical stimulus, either in the form of smell or in the form of taste. Now we have accordingly, number one, olfactory receptors, concerned with the sense of smell. We have antennae, the maxillary pulps, the labial pulps, they have the ability of perceiving the sense of smell. The maxillary pulps and labial pulps, antennae, maxillary and labial pulps. Then the gustatory receptors concerned with the sense of taste. And again they are found in the labrum, this upper lip. And also we have the maxillary and labial pulps. These are all the structures concerned with what we have the food capturing and then crushing the food, biting and chewing. So we have the taste receptors, otherwise called the taste receptors, found in the labrum, maxillary and labial pulps. Then thermoreceptors concerned with the reception of what is called thermal stimulus, what we have either the heat or the cold. Now they are found normally in the tarsal segments. We have, you see that one tarsus is made up of 5 different segments in the leg. The last segment is called the tarsus, which is being divided into tarsal segment. Now the thermoreceptors are possibly found in the first, second, and then the third segments of what we call the tarsus. Each one is called as what is called tarsomere. Tarsomere. See, the last segment, suppose you are taking the leg, it is 5 segment. This is 5 segment. These segments are called the tarsal segments. Now we have the that is what we have, the thermoreceptors concerned with the perception of heat. They are found in the first, second and third segments. Now this is number 1, number 2, number 3, this is number 4 and number 5. Here we have the what is called the thermoreceptors are found in the first, second, third segments of tarsus. First, second and third segment of tarsus. Then tangoreceptors, they are normally called as the touch receptors, normally found on the antennae. When the animal is moving, you know that when the antennae are projecting forward, if there is any obstruction that is felt by the antennae, so that the animal is taking its diversion from that obstruction. So anyway, the tangoreceptors, they are simply called as a sense of touch. So these are the 4 different types of receptors. 1, we have the mechanoreceptors. 2, the chemoreceptors. And then we have the thermoreceptors concerned with what we have the temperature perception, particularly found in the dorsal segment. And finally, the tangoreceptors concerned with the sense of touch as well as the pressure in a particular locality. And they are present normally on the antenna. So the antenna is the main organ concerned with a number of what we call stimuli perception, either olfactory receptors or mechanoreceptors, or we have the tangoreceptors. Okay, excepting the thermoreceptors, all other functions being performed with the antenna. Also, it is normally not concerned with what is called sensory taste, sense of taste, but it is concerned with olfactory sense. Okay, now these are all some of the receptors concerned. Now, compound eye. So the nature of the eye in the case of cockroach is compound. Normally, in the case of all arthropods. So what do you mean by compound eye? A compound eye is the one which is made up of many simpler units. Each unit is called what is known as ommatidium. That means each ommatidium has a single lens. So an eye made up of many lenses is called compound eye. Here we have the unit ommatidium is present. So we have many ommatidium which are hexagonal in nature. And each ommatidium, the unit of compound eye, that's a question. The unit of compound eye is called ommatidium, is having a lens. Now, just let's go for the location of the compound eye. We have a pair of dark colored kidney shaped structures. That is normally the compound eye present on the dorsolateral sides of the head. So suppose we have the head region. This is the head, and here this is the compound eye. This is the compound eye. This is the compound eye. So each compound eye is made up of nearly 200 hexagonal units. The units are called ommatidia. So this is one question. What is the unit of compound eye? The unit of compound eye is ommatidium. Plural ommatidia, singular ommatidium. So nearly each eye we have 200. That is outer shape hexagon. They are present actually in each compound eyes. So with the help of this compound eyes, normally the animal can form several images of an object. So what's the meaning for that one? Several images of an object. Suppose it's a compound eye. It's made up of many units. And the units are called ommatidia. Now this is each one ommatidium. This is ommatidium. Ommatidium. That's the unit of compound. When a person is standing in front of the compound eye, now we have, that one using single eye, single lens, we can see many objects. We have the ability of seeing many objects by using a single lens or single eye. But here in each ommatidium there is a lens. The image formed here is a collecting effect of many lenses or many ommatidia. So only a part of the image is normally perceived by this ommatidium. For example, the head region. The next part, it is by this ommatidium. So the image formed is actually bits. So a single object's image being perceived in the form of many bits of images. This is because of the unit. So such a vision is called mosaic vision. A single ommatidium perceives only a part of what we have the body's image and doesn't actually form the image of the entire animal or entire object standing in front. So we have the image formed is a collective effect of many lenses, that is many ommatidia. So it is in the form of a mosaic. Only part you can see the head here, the tail like that one. That's such a vision is called mosaic vision. Okay, I'll give you more information. So with the help of common eyes, a cockroach can form several images of an object, not a single image. This kind of vision is called mosaic vision. So what is the type of vision seen in the case of cockroach? It is called mosaic vision. And again you see that one image formed is not clear because of the overlapping of the images. That is in the case of nocturnal animals like cockroach. But in the case of, for example, houseflies, there is no overlapping of images. Now the common image perceives many bits of images of a single object. That's why the image is called mosaic image. Now in the case of cockroach and nocturnal animal, there is an overlapping of images. That's why the image is not clear. Such an image which is formed because of the overlapping of images by different compound eyes is called superposition image. That is seen in the case of nocturnal animals. But in the case of, you see that one housefly, a diurnal organism, a diurnal insect. Here there is no overlapping of images. Though we have the mosaic image, there is no overlapping of images. A clear image is produced in the case of housefly, a diurnal animal. That is called, you see that one, apposition image. So superposition in the case of cockroach. See, we have superposition image. Superposition, what we can say commonly known as the mosaic vision. In all cases, mosaic vision. There is nothing but the formation of many images in the form of bits. So the image formed is a collective effect of many lenses. A bit image is formed only in one material. Now the superposition in the case of cockroach, otherwise called as a nocturnal vision. Nocturnal vision. Because it is seen in the case of nocturnal animal. Here the image formation is not clear because of overlapping. Now another, actually, that is what we have image, mosaic image or mosaic vision apposition. For example, the case of housefly. In the case of housefly, it is called diurnal vision. Here there is no overlapping of images. This is because of the presence of one sheath, black pigmented sheath. That is not necessary for you. So here the image form is normally clear. Here there is no overlapping of images. Such an image is called apposition mosaic image. So in both the cases mosaic vision only because it's a collective effect of many material. Now superposition image is seen in the case of nocturnal animal, hence called nocturnal vision. And apposition image is formed in the case of housefly, a diurnal organism, that is called diurnal vision. But in all cases we have only the mosaic vision, a collecting effect of many lenses. So each material consists only a part of actually image of an object. So that's why we have bits of images. So many bits together form what we have one image. That's why it's called a mosaic vision, as in the case of the scattered stones in a tiles, the mosaic tiles, scattered stones, like that only it's appearing. That's why it's called as a mosaic vision. Now this kind of vision is known as mosaic vision because we see that one we have the image formation, a collective effect. So this is with more sensitivity with the less resolution. We have more resolution power. We can be able to just pinpoint the difference between 2 points. That is called the resolution power. But here it is not able to pinpoint the distance between the two objects. That is called actually less resolution. We have more resolution power. The insect has less resolution power. So it is because of overlapping. That is, the image formation is not clear. That's the meaning. The image formation is not clear. This is because of the overlapping of the images formed with the different parts of the object. So that's why the image is not properly formed, less resolution. Now if the images are formed by overlapping, then this type of vision is called superposition image. Because of the overlapping, the resolution power is less resolution, that power is less. Okay, and as it is seen in the case of nocturnal animals like cockroach, this vision, the superposition image is also called nocturnal vision. Contrast to what we have the diurnal vision seen in the case of, that is housefly, and that one is called apposition image. There is no overlapping of images. So with that we have concluded the sensory structures of compound eye and the sensilla, the mechanoreceptors, the chemoreceptors, thermoreceptors, and also touch receptors, what is called the tango receptors. Now we go for the reproductive system. You know the animals are normally unisexual, sexes are separate. We have a separate male reproductive system and a separate female reproductive system. Now what are the components of the male reproductive system? Now this one consists of a pair of testes. They are present in segments between actually 4 to 6. They are present segments between 4 to 6 in the abdomen. The ovaries are present between the segments 2 to 6. Here the testes are found in, they are lying in the segments between 4 to 6. Now from each testis a vas deferens arises. Now I will show the picture now. Now this is a male reproductive system. Now these are all the testes located in segments 4, 5 and 6. And from each testis we have, you see that one, this is the testis, a small thin vas deferens arises. This is the vas deferens. Here you see that one, this is the vas deferens. And this is what we have, the testis. Then the vas deferens pass through what is called a seminal vesicle into the ejaculatory duct. Now this is the outer passage, what is given, the ejaculatory duct. This is the ejaculatory duct. So the vas deferens opens in the ejaculatory duct by passing through the seminal vesicle. Now this is the seminal vesicle. Now the seminal vesicle is produced into many diverticular finger-like structures, giving the appearance of a mushroom. Hence it is called mushroom-shaped gland. Hence it is called mushroom-shaped gland. Now this is what we have, the mushroom-shaped gland, and that is formed by the repeated branching of the seminal vesicles. So we have testis, the vas deferens, and that vas deferens leads into the ejaculatory duct. The meaning for that one, the one which opens outside. Now by passing through the seminal vesicle is produced into many finger-like projections, giving the appearance of a mushroom, hence called what is known as mushroom-shaped gland. Now the ejaculatory duct opens into the genital pouch, the one which is present, you see that one at the opposite end of the animal, into which the anal openings, and also we have the ejaculatory duct of the reproductive tract opens. Now associated with what we have, the male reproductive system, we have phallic gland. This phallic gland is also called conglobate gland. Now it is concerned with the formation of sperm bundles. It secretes some secretions. It makes the sperms together or glued together, stick together to form bundles. Such sperm bundles are called spermatophores. So the spermatophores are formed and then released into the seminal vesicle, and they are being stored. At the time of reproduction and at the time of fertilization, normally they are released and collected by what we have, the female, and there you have what we have, the fertilization occurs and formation of ootheca. So the phallic gland's function is secreting fluid which makes which makes the sperms to bundle together, and such a bundle of sperms is called spermatophores. Now we have, this is what we have, that is the genital pouch. The genital pouch is normally surrounded by some chitinous plates commonly called gonophyses. Out of actually are phelomeres. We can say phelomere or gonophyses. There are three phelomeres, one ventral, another two are lateral, right and left sides. Here it is given right phelomere, this one, and then we have the ventral phelomere, this one, and we have also the left phelomere. They are commonly called as gonophyses. They are all useful in copulation. So they are nothing but the chitinous plates surrounding the male genital aperture, 3 in number, otherwise called as phelomeres. So they are called, what is called gonophyses or phelomeres. I will give you the picture now. Now we have vas deferens. Now a pair of testes only, but found in 4 segments, I made a mistake. 4 to 6 segments, 4, 5 and 6, that's the 3 segments only. A thin vas deferens arising from that one. It opens into the ejaculatory duct by passing through the seminal vesicle. What I showed you, that is nothing but the mushroom shape. This is what is called seminal vesicle. It's normally not a sac-like structure, but it's being produced in many finger-like projections, giving the appearance of a mushroom. Hence also called mushroom-shaped gland. Nothing but the seminal vesicle one. Okay, seminal vesicle one. Now the ejaculatory duct, that is the last final part, which opens into the male gonopore, which opens outside by means of male gonopore or male genital aperture. The one which is situated just ventral to the anus. So the anus, the male gonopore, the male gonopore, all being present in the genital pouch of the male, a space in which the genital aperture, the anal opening, all open. So we have dorsally the anus in the genital pouch and ventrally the male gonopore. Now what are the accessory reproductive glands? I mentioned what is called the mushroom-shaped gland. It is formed by the repeated branching of the seminal vesicle. Now, whose secretions responsible for to make the sperms glued together, stick together? Glued means normally sticking. Stick together to form a bundle of sperms called spermatophores. That is called the sperm bundles, spermatophores. Stick together to form sperm bundles called spermatophores. Now, the sperms in the form of bundles, what we call the spermatophores, are received by the seminal vesicle and stored in the seminal vesicle and released during copulation. So, are stored in the seminal vesicle, the storehouse, and released during copulation. Okay, the sperms are not found in singles, they are found in bundles. That is being done with the help of what is called, that is the phallic gland or conglobate gland. Phallic gland or conglobate gland. A single phallic gland or conglobate gland is present, concerned with the secretion, and such a secretion is responsible for making the sperm to form the sperm bundles, and which is being stored in the seminal vesicle, and at the time of copulation it is being released into the genital pouch. Now, external genitalia. This refers to what we call the organs found outside the body but close to the genital structures, the openings. Now, these are represented by, I mentioned, male gonopophysis, nothing but chitinous plates, otherwise called as the philomeas I mentioned above. There are three in number. One is ventral and two are lateral, right and left sides. So anyway, they are concerned with the inother one, just helping copulation. Now, these are chitinous asymmetrical structures not having a specific just shape, asymmetrical structures surrounding the male genital aperture, helping in what we have copulation. So gonopophysis, chitinous plates, three in number, otherwise called as the philomeas, surrounding the what we have the male genital aperture, found in the genital pouch, concerned with copulation. Now, the female reproductive system. Here it is also formed of a pair of ovaries present in segments between 2 and 6, 2, 3, 4, 5 and 6, because they are somewhat elongated. Now, we have the ovaries, a pair of ovaries, number 1, lying in second to third segments. Second to third. That one is 4, 5, 6 and this one second to third. Each ovary is made up of cylindrical tubes, what are called ovarian follicles. Or we can say ovarioles or ovarian tubes. In each ovary there are 8 ovarian tubes. There are 8 ovarian tubes, normally called as ovarioles, in which are developing a chain of eggs. A continuous chain of eggs are developing. Continuous chain of eggs are developing. So we have containing a chain of developing egg. There's about 8 ovarioles on either side. Totally we have 16 ovarioles are present. Why I am telling that one? Corresponding to the number of ovarioles, at a time a cockroach releases 16 eggs. 16 eggs are released at a time. 8 from each ovary, 1 from each ovariole or ovarian tubes. So the number of eggs produced at a time is equal to the number of ovarioles. So on either side we have 8, 8 plus 8, 16 ovarioles. So we are getting 16 eggs are released at a time. Now, the oviducts from each ovary unite together in a single median oviduct. The median oviduct, also called as vagina, which opens into the genital pouch, or the genital chamber. Now, a pair of spermaticae and a pair of colloidal glands also open into the genital chamber. A pair of spermaticae, normally found in the 6th segment, but open into the genital pouch separately, which opens in the genital chamber. So they are concerned with the reception of the sperm from the male during copulation and storing it. And during fertilization, they are released from what we call the spermaticae. So in male, the seminal vesicles are concerned with the storage. In females, the spermaticae are concerned with the reception of the sperm and storing it. And at the time of fertilization, they are releasing eggs. Now we have, you see that one, a pair of ovaries in segments. They are having some filamentous structures. And now there are 8 ovarian tubes, ovarioles. Each one is called egg chamber. At each time, each ovarian tube produces 1 egg. So here we have 8. Maybe the number is less. Actually, this is present on the other side. So 8 ovarian tubes, and each one produces 1 egg at a time. So we have 8 on either side. Total number of eggs released is equal to the total number of ovarian tubes. What we have just with the ovarian tubes. Okay, and they are cylindrical in nature and having what is called eggs produced in different stages. So 8 ovarian tubes or 8 ovarioles. Now from each ovary there is a duct. This is a oviduct. The two oviducts join together and open into the genital pouch or genital chamber. So this is two oviducts joined together to form a common oviduct or vagina, which opens into the genital chamber. Now this is a seminal vesicle, spermatheca, 2 in number. Represent 1 spermatheca receiving the sperm from the male and storing it. And also connected to what we have, the genital chamber, this is a collateral glands, branchial collateral glands, concerned with the formation of the egg case, ootheca, concerned with the formation of egg case or ootheca. Now this is the genital chamber. Now for placing the eggs at right place, there are some structures. They are called as a chitinous place for actually placing the eggs. They are also called number 5. As they are placing the eggs at the right place where you have the humidity is available, where you have the nearest source of food, and that is called ovipositor. One used for placing the eggs in the right place. Now, what are the other structures? Now let's go for it. Now we have actually the chamber. This is the genital chamber. Now the anterior part is called gyneterium. This is the gyneterium, anterior part of the genital chamber. Then the posterior part is called oothecal chamber. Now this is the place, this is a oothecal chamber. This is a total chamber, what we have the genital chamber. So this is what we have gyneterium, this part, what I mentioned. And this is what we have the oothecal chamber. Now normally the fertilization occurs in the gyneterium. And the formation of ootheca, the egg case, is formed in the oothecal chamber. That's why accordingly they are called as gyneterium and the oothecal chamber. So the anterior part we have the gyneterium and the posterior part we have oothecal chamber. Now what is fertilization and development? Now normally sperms are transferred through spermatophores in the form of spermatophores from what we have the male to the female, and they are being collected and stored in the seminal vesicles. In the what is called spermatheca. Seminal vesicles found in male concerned with the storage of sperm. And we have, that is what we have, spermathecae are structures found in females concerned with the perception of the sperm, that is the reception of the sperm and storage of sperms. Now fertilization. Now the sperms received by the spermathecae are released into the genital chamber. Eggs are also released, all 16 eggs are released, and fertilization of 16 eggs occur. In the gyneterium, I mentioned. So 16 eggs are released at a time. They are being fertilized by 16 different sperms released from the spermathecae of the female. Now, and cocoon formation, what is called the egg case in the oothecal chamber. The cocoons are secreted or formed or produced by the collateral gland, the branchial gland what is shown. Now the fertilized eggs are encased in capsules called ootheca. Normally there are 16 eggs which are placed in 2 rows of 8 each. But because of certain factors, some of the eggs may die. So we have range has to be given. In egg capsule, we have 14 to 16 eggs. 14 to 16 eggs. So 16 eggs are released. Maybe a chance of destruction of 1 or 2 eggs due to climatic condition. Generally we can say 16 eggs are released and they are all being fertilized, all being encased, closed or placed inside the capsule, what is called ootheca, otherwise called as a cocoon also, and containing 16 eggs under normal conditions. That is what we call 14 to 16. Now they are dropped into the suitable surface with the help of what is called actually ovipositor. In places where we have the relative humidity is there and available source of food, that should be there nearby, an available source of food. I mentioned about, on an average, females produce 9 to 10 ootheca. Number of ootheca produce 9 to 10. They are producing continuously. And each ootheca contains 14 to 16 eggs. This is the number of egg cases, 9 to 10. 9 to 10. We will produce 9 to 10. And each ootheca contains 14 to 16. Normally, average, I mentioned already 16. But because of something, we have to give the range, 14 to 16 eggs. The development of Periplaneta americana is called what is known as parametaboly. So we have the word metaboly is related to reproduction. There is one question in the question paper. The word metaboly is related to what? This is one question came in the entrance examination. So the word metaboly is nothing but metamorphosis. This is the technical word used for metamorphosis. Metaboly. What is metaboly? This is nothing but metamorphosis. Technically called metamorphosis. Metamorphosis. See, in the young ones, normally in the case of metamorphosis, where you come across metamorphosis, in the case of animals which have actually no direct development, they have indirect development. What do you mean by indirect development? The meaning for that one, there is a larval stage that is called indirect development. The larva has to undergo series of changes to form the adult. Such changes together called metamorphosis. The sequence of events happening to convert the larva into adult is called metamorphosis. Technically called metaboly. Based on the nature of metamorphosis, we have complete metamorphosis, then is called holometaboly. Complete metamorphosis, as in the case of moth and butterfly. Or incomplete metamorphosis, as in the case of grasshopper, cockroach, then is called hemimetaboly. Hemimetaboly, incomplete metamorphosis. Some cases we have incomplete metamorphosis and also it is taking place slowly. For example, cockroach, that is called parometaboly. So incomplete metamorphosis which occurs gradually and slowly is called parometaboly. So I have the notes, we know that one here. So the development of Periplanet americana is called as parametabolous. Parametabolous. The meaning for that one, incomplete metaboly, gradual metaboly. That is called incomplete gradual metamorphosis. Now the number of, actually the young one of cockroach is called nymph. And now the nymph has to undergo nearly the moles 13. The total number of moles 13. In housefly it is only 2. In the case of black insect this is 3. In the case of silk moth it is 4. But here you see that one number of moles 13. This is one question. How many moles that cockroach normally has? So how many eggs are present in each egg case? Utika 14 to 16. How many egg cases have been produced by a female cockroach? That is 9 to 10. The average number of Utika produced 9 to 10. The average number of eggs present in each chamber or each Utika is called 14 to 16. The number of moles is called 13. Now next to the last, what we call the nymphal stage. The wing pads develop. That is after the last mole only we have the formation of wings in the form of small pads. Now after the last, so only adult cockroaches have wings, you know that one. Next to the last nymphal stage, after the nymphal stage, after the 13th molt, just what will happen? The following visible changes occur in both appearance of fur and wings. This is the question. What is the visible change that occurs after the last molt? This is 2 years back the question came. Okay, remember this one. What is the visible change occurs in cockroach during metamorphosis after the last molt? That is formation, rudimentary wings develop. You see that one? So both forewings and hindwings develop. Formation of fore, wings and hind. This is a question, neat question. After the last molt, the next stage, what we have, the formation of, that is fore and hind wings develop. This is one question, remember that one. The number of molts, number of what is called the eggs present in each cases. So with that I concluded what we call the cockroach. We have to go for one more structural organization, very simple animal, a vertebrate, what we call the frog. Okay, so we have to take that one in the next class. Okay, let's continue in the next class. Till then, goodbye. Thank you.